Hello dear students, how are you all? Welcome to Tejama YouTube channel. So in this session we are going to discuss about a very important concept that is called electric field. So this is one of the concepts from electric charges and fields chapter. Till now we have learnt about charges and electric force, that is Coulomb force. Now we will learn a new concept, electric field. Then this is one of the important concepts in this chapter. Why? Because from now onwards whatever the content is there, that would be completely based on this electric field. Like we derive the electric field due to dipole along the axis, along the equatorial. Gauss law is there and its applications, and in special cases like motion of charged particle in electric field and pendulum concepts. In all those cases we use the formula for electric field due to point charge, and different derivations are there. We'll learn about them also. So what is the electric field due to straight linear wire? What is the electric field due to curved wire? What is the electric field due to plane sheet? All this comes under special cases. For JEE it is very important. Okay, I'll explain each and every concept in detail. So it will be like what is that different parts of the videos. So in each video I'll be explaining few concepts. I'll mention what is there in your in that particular video, everything in detail in the description, so you can follow it. Okay, so now let us start with what is electric field. Dear students, in gravitational field, or in the chapter gravity, we have learnt what is gravitational field, right? It is a field around the earth. For example, if you consider the gravitational field of the earth, ನೀವು ಅರ್ಥನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಅರ್ತ್ ಸುತ್ತ ಏನಿದೆ ಗ್ರಾವಿಟೇಷನಲ್ ಫೀಲ್ಡ್ ಇದೆ. How to know whether the gravitational field is there or not? You can just throw an object here, it will come back. So why the object comes back? Because there is a gravitational field here. The field is nothing but the space in which other masses can experience gravitational force. ಇಲ್ಲಿ ಫೀಲ್ಡ್ ಇದೆ ಅಂತ ಗೊತ್ತಾಗಬೇಕು ಅಂದರೆ ಸಿ ಇಲ್ಲಿ ಗ್ರಾವಿಟೇಷನಲ್ ಫೀಲ್ಡ್ ಇದೆ. ಹೇಗೆ ಅಂತಂದರೆ, ಸೊ ಇಫ್ ಐ ಲೀವ್ ಇಟ್ ವಿಲ್ ಫಾಲ್ ಡೌನ್. ಸೊ ದಿ ಆಬ್ಜೆಕ್ಟ್, ದಿಸ್ ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಗೆಟಿಂಗ್ ಅಟ್ರಾಕ್ಟೆಡ್ ಟುವರ್ಡ್ಸ್ ದ ಅರ್ತ್ ಮೀನ್ಸ್ ಇಲ್ಲಿ ಗ್ರಾವಿಟೇಷನಲ್ ಫೀಲ್ಡ್ ಇದೆ ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೋದು. ಸೊ ವಿ ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ಹಿಯರ್ ದರ್ ಇಸ್ ಎ ಗ್ರಾವಿಟೇಷನಲ್ ಫೀಲ್ಡ್. Just like that we have electric field. So if I consider this is the charge, let's consider this is the charge. So if there is a field around it, other charges, let's consider this another charge, negative charge. Okay, if there is a charge, if it is a positive charge, there will be field around it, in which if you place a negative charge, it will get attracted, or if you place a positive charge, it will get repelled. So by considering the force, we can define the field. Okay, so in short, electric field is defined as electric field is defined as electric force acting on unit positive charge. Mathematically it is given by E is equal to F divided by Q naught. If I consider for point charges, consider here we have electric field. Okay, here we have a charge Q. I need to find out the electric field of this charge at a distance here. How much distance? R. So here we have another charge Q naught, which experiences a force in this direction F. The force between these two is given by F is equal to 1 over 4 pi epsilon naught Q into Q naught divided by R square. ಅಲ್ವಾ, ಇದನ್ನು ಕೂಲಂಬ್ ಫೋರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. Now according to this formula, if I consider E is equal to F divided by Q naught, so ಏನು ಬರುತ್ತೆ, this divided by 1 over 4 pi epsilon naught Q naught divided by R square divided by Q naught is there. So Q naught get cancelled. So E is equal to 1 over 4 pi epsilon naught Q divided by R square. This is the electric field due to point charge. So electric field is defined as the electrostatic force, that is Coulomb force, acting on unit positive charge. E is equal to F by Q naught is the general formula. So then we have, this is the electric field due to point charge. Do remember, if I have a point charge due to which the electric field at this particular point is given by this one. And here electric field I'll write it as E. Electric field is a vector quantity. Okay, vector quantity. And what is the unit? Unit of electric field strength at a point. So electric field strength is given by Newton per Coulomb, force by charge. So Newton per Coulomb. Okay, now Newton per Coulomb is a unit of electric field strength or electric field or electric flux density also we call. Next one, or we can also write it as volt per meter. Okay, volt per meter. Or if you consider flux density, Weber per WB will write Weber per meter square. Weber per meter square. These are the different units of electric field. So from this formula, this is the unit. We have one more formula for electric field that you will learn in the electric potential and capacitance chapter, and this one you will learn in this chapter only, but in the concept of electric flux. So what is the electric field due to point charge? This is the one which is very, very important. This is electric field due to point charge. Now, for competitive examinations like Kcet and Comet K, the dimensions of electric field is very, very important. So let me derive the dimensions of electric field. So if I want to write the dimensions of electric field, so I will write the units of electric field. So let us take E is equal to what? F divided by Q. Force is given by mass into acceleration divided by charge is given by current into time. Yes or no? Because current is equal to charge by time, charge is equal to current into time. So for mass, the unit is kg. For acceleration, meter per second square divided by current, it is ampere, time, it is second. So this is nothing but kg meter per second cube per ampere. So what is the dimensions from this? For kg it is m power 1, meter L power 1, second T power minus 3, and ampere A power minus 1. Correct now? So these are the dimensions. Okay. So then we have the properties of electric field lines. Okay. So this is about the basics. Then we'll learn about the properties of electric field lines. Okay now? Okay, so next we have the electric field lines and its properties concept. So this is how the electric field lines looks for different cases. This is, we have charge which is greater than 0, that is a positive charge. For positive charge, electric field lines are directed radially outwards and they extend till infinity. Okay, and for negative charge, that is Q less than 0, the electric field lines are directed radially inwards. So look at the arrow marks. And this is a dipole. What is dipole? Two equal and opposite charges separated by small distance. Example, you can consider HCl, hydrochloric acid, HCl. So in that molecule, the electric field will be like this. They are directed from positive charge, originate from positive charge, insert negative charge. And then here we have two like charges. You can take plus plus or minus minus also. If you take plus plus, consider the what is the direction of electric field outwards, and for negative charge it is inwards. So like charges with equal magnitude, number of field lines will be same on both sides. See, q1 is equal to q2, 1 2 3 4 5 6 7, 1 2 3 4 5 6 7. Number of field lines same idea, yes or no? Then here if you consider, here number of field lines are more. I have drawn this diagram bigger, the charge bigger, just to show that charge is larger, q1 is larger than q2, like charges only plus plus, but this magnitude is more, so number of field lines are more. This magnitude is less, so number of field lines are less. Okay, then we have uniform electric field, which is represented like this, equidistant parallel lines, and this is non-uniform electric field lines. This is how we represent non-uniform electric field lines. Okay, so this is about this. Now in theory they will ask, in board exams they will ask, mention the properties of electric field lines. The same points you can mention. Okay, along with these points you can also write, no two electric field lines intersect each other. Electric field lines do not intersect each other. Okay, then electric field lines are perpendicular to equipotential surface, that you will learn in the electric potential and capacitance. Then you can write, electric field lines do not form closed loops. Electric field lines do not form closed loop. And along with this you can tell electric field lines are directed outwards and inwards, and what is that, they originate from positive charge, insert negative charge. This is how electric field lines looks like. All these properties we can add. Okay na? And they're continuous. So electric field lines are continuous without any breaks. This is the theory part. Okay, now I will move on to the next case, like special cases which are important for your examinations, both competitive and board exam. Clear? Yeah. Okay, now let us apply this electric field to some examples, and let us learn more about it. Now let's consider, there are two charges, Q and Q. They are separated by some distance r, so magnitude is same. Okay, this is the first case in this. Let's consider, find the electric field at the midpoint. This is the midpoint. What is the electric field at the midpoint of two similar charges along the line joining the two charges? So here, if I consider this distance is x, this distance will also be x. So same charge, so same distance of separation is there. At this particular point, electric field due to this one will be radial outwards. If it is positive charge, electric field is directed radially outwards for positive charge. So this is also positive charge, electric field is directed outwards. Okay, so what is the magnitude of electric field? E is equal to, for point charge it is given by 1 over 4 pi epsilon naught q divided by x square. So this one also same, this one also same, but they are in the opposite direction. So electric field is a vector quantity, so net electric field is E minus E. They are equal and opposite, so it is 0. So the electric field at the midpoint of two charges, okay, along the line joining the two charges, is 0. That is called null point. Okay, this is called null point. So based on this, null point. Based on this, you will get numerical type question. I will take a separate class in the different video. I will explain null point problems in detail. Okay, now let us take second case, where I have an equilateral triangle. Okay, this side, this side, this side are same. Let's consider this is, you can take it as A. So here and here I have two charges. It is an equilateral triangle. Find the electric field at the third corner. Here what is the electric field? Due to Q, electric field is outwards. Due to Q, electric field is outwards with same magnitude. Magnitude is same. This angle is how much? 60 degree. This is also same angle. The resultant electric field will be in this direction. So first I will write what is E. E is given by 1 over 4 pi epsilon naught q divided by a square. This is the distance. But what is ER? E resultant. E resultant can be given by parallelogram law of vector addition, that is E square plus this E square plus 2E into E cos 60 degree. Correct now? Cos 60 is 1 by 2. 2 and 1 by 2 get cancelled. So E resultant is equal to E square plus E square E into E square 3E square. That is root 3E is your answer. So you can calculate if Q value is given, A value is given, substitute, multiply it by root 3, you will get the answer. Simple as that. So there is one more case. C. Okay. So let's consider this is a square. Here, here, here. All these sides are equal. This is Q, this is Q, this is Q, this is Q. So let me take out one more. So they will ask you to find out the electric field here. So let me solve this. Electric field due to, let me consider this A, B, C. Electric field due to A is in this direction, that is EA. Electric field due to C is in this direction, that is EC. Electric field due to B is in this direction, EB. I need to add these three. EB. So for EA charge is Q and distance is A. For EC charge is for EA charge is Q, distance is A. For EC charge is Q and distance is A. So that means EA is equal to EC. So EA is equal to EC, that is equal to KQ by A square. K means 1 by 4 pi epsilon. That is constant. Here dielectric medium is not there. Let us directly write 1 by 4 pi epsilon as K. Now what is EB? For that you need this distance. What is the diagonal? I have already told you it is root 2A. By using Pythagoras theorem, you can just solve this. So EB is equal to KQ by root 2A whole square. Root 2A whole square. That is KQ by 2A square. Now I need to find the resultant of EA and EC. So EA and EC are having the angle 90 degree. So EA square plus EC square cos 90 is 0. So EA is E. EC is also E. E square plus E square is 2E square. So root 2E will come. So EAC, by using this formula, you will get root 2E. Just add these two, you will get net electric field. Net electric field is equal to root 2E plus this one is 1 by 2E. This is KQ by A square is E divided by 2. Okay, just take E common, we will get root 2 plus 1 by 2 E is your answer. Any doubt in this? Similarly, in the exam, in the board examination also, they will give two charges. Let me take here. Okay, so here is right angle triangle is given. For competitive exams also it is very, very important. Okay, they will give one charge here, one charge here. This is 90 degree. Okay, so they will ask you to find out electric field here. Let's consider this is 60 degree. What about this? This will be 30 degree. If this is A, some distance they will give. This is B, this is square root of A square plus B square. The distance you have to find out. So find the electric field here. These kind of questions also sometimes they will ask. So electric field due to this one and electric field due to this one will be different because distance is different. That you have to find out and apply parallelogram law of vector addition that you have studied in first PUC, that is R is equal to square root of a square plus b square plus 2ab cos theta. 2ab cos theta. Is it clear? So let us learn about few more examples on this particular topic, that is electric field. Okay. Okay. So next we have this. In these all diagrams, the charges are distributed. So at the point which is marked as x, so the electric field is 0. Okay, do remember this. In this case, we have two charges, two like charges, maybe plus plus or minus minus. At this point, the electric field will be 0. It's because the electric field lines gets cancelled out. Here, we have an equilateral triangle. So Q, Q, Q. At a distance, so what is this distance? Circumradius. Okay, in the previous video, I have already given you circumradius distance, that is given by side divided by, so any one side divided by, so 2 times sine 180 divided by n. So by using this, you can calculate. This is n value is 3. Substitute n value, you will get to root a by root 3. And here at the center of the square, at a distance a by root 2, also electric field is 0. Here E is equal to 0. E is equal to 0. Here E is equal to 0. Here E is equal to 0. So where is the charge, sir? You can consider charge Q, 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 Q. So there is a charge in this polygon, or the vertices of a polygon, a regular polygon. Okay, so here also we have a square, here we have a pentagon, here we have a hexagon, you can consider hectagon. Okay, so here we have uniform charge distribution on a ring, uniformly charged ring also. So the electric field at the center of the uniformly charged ring is 0, and here also electric field is 0. In competitive examinations, they will ask questions on this. So I thought it is useful to tell it, so I'm telling it. I will solve few numerical questions also based on this. You can follow it and practice well. Then we have application based questions, or the topics like motion of charge particle in electric field, and different applications like dipole, electric field dipole, linearly charged wire and plate. Then we have a sphere. So we'll learn one by one in different videos. Thank you. We'll meet you in the next video.